Very good morning students, welcome to my channel Miracles of Math. So in the previous lectures, after arithmetic progression, we started what is geometric progression, and we also derived a formula for sum to n terms. So what is the formula for sum to n terms? If you remember, Sn is equal to a into r power n minus 1 by r minus 1. So what is a? A is the first term, and what is r? R is the common ratio of that geometric progression. When there is a number n, okay, n represents that there are finite number of elements, 10 elements, 20 elements, okay, number of terms, 20 terms, 100 terms, 1000 terms, whatever it is, but it's a fixed number. Now tell me in a case if n is infinite, that means the progression is never ending, it is moving on forever. Can we find the sum of that infinite series? Can we find the sum of that infinite series? I'll give you a small example. Let us take the first number as 2 or 3. Let us take 3, and that is a. And let us take common ratio as 2. Common ratio as 2. So this is 3, and then we'll be having 6. The next element a into r. Next one 6 2 is 12, 24, 48, and so on. Correct. This is a geometry progression. What is 100th element, or what is 1000th element, what is 10,000th element? If you go on like this, it will be very huge number. As we go to infinity, even the number is very huge that we consider that as infinity. So when you sum all these, what you get? Again an infinite number, very large, we don't know. Still it is not an ending number, right? So as we are having infinite terms, even the sum goes on increasing. So can we find the sum to infinite terms in this type of series? No, we cannot. Let us take one more example. Let us take one more example here only. Let us take the first element as 2. Again the common ratio, let us take it as 2. Okay, first element is 2, common ratio is 2. The second element will be common ratio, I am taking it as now 1 by 2. I am considering my common ratio as 1 by 2. So 2, the next element will be 1. The next element will be 1 into 1 by 2, that is 1 by 2. The next element 1 by 4. Next 1 by 8, 1 by 16, 1 by 32, and so on till if only you are going to infinity, 1 by very large number. 1 by 4, 8, 16, 32, 64, so on, 1024, 2048, 4096. And again, still going on, you will get a very large number infinity. So when you are finding sum to infinite terms, can we find the sum of this one? Can you find the sum of this one? Yes, you said that it is infinity. We cannot find, but it's a very large number. What about this one? See here. Number 2 plus 1, this is 3. 3 plus is 0.5. This is 0.25. 1 by 8 is 0.125. 1 by 16 is 0.0625, I'm not sure, just whatever it is. So go on, if you're adding all these, okay, so it is 5, 7, 11, 12, 13, 5, 6, 7, 8, 9.93, 3 plus 0.93, okay, so it is around 3.93, or you can say it is near to 4, it is near to 4. So what can I say that this progression or this series, the sum of series, is converging to a number 4. You can say, Mr. we'll go still to infinite terms. Still we'll go to infinite terms. Then it may cross 4, or it may go to 5, it may go to 6, it may go to 7, it may increase. Just make sure that you just keep your thoughts here. As we are decreasing, as the numbers are decreasing, 0.5, 0.25, 125, 0.06, the next one is 0.00. The next one is 0.000, the next one 0.000, so on. What are we getting? We are getting a very infinitely small number, which doesn't make any difference in the sum. It will be 3.93, 3.94, 3.99999999, but it will never cross 4. How can I say that? Yes, so that one we will see using the formula. See here. So whenever you have a formula here, and whenever the common ratio is a very small number in the sense, what is the difference between these two? Even 2 is also a small number. 2 is also a small number. 1 by 2 is also a small number. What is the difference between these two? Can you tell me? The difference is Here the common ratio is greater than 1. Here the common ratio is less than 1. Whenever we have a number common ratio less than 1, so go on multiplying, we get least numbers. The number 1 by 4 is greater than 1 by 8. 1 by 8 is a small number. 1 by 16 is smaller. 1 by 32 is still smaller. So as you multiply with a number less than 1, the value decreases. So considering the common ratio which is less than 1, we can even go in the other way, in the negative direction also. That means when your common ratio is between minus 1 to 1 and 0 is not considered in geometry progression. Whenever I say R, common ratio cannot be 0. Okay, so that definition is already there with us. So when the number is between minus 1 to 1, when the common ratio is between minus 1 to 1, as n tends to infinity, n tends to infinity. What is the meaning of n tending to infinity? When we are going to infinite terms. As n is tending to infinity, r power n, as r is very small number, so go on increasing, r square, r cube, r power 4, r power 5, r power 6, r power 10, r power 100, all these were almost infinitely small, which is considered to be equal to 0, which is approximately equal to 0. So you can think like this. What is 0.1? 0.1 whole square is 0.01. 0.1 whole cube, 0.001. 0.1 whole power 10, 0.000000, then 1. So as you increase this power, this value almost tends to 0. The same thing. As the power is going to infinity, we say that r power n tends to 0. So if r power n is tending to 0, so this value becomes 0. Yes or no? So what is Sn we are having? Sn is equal to a into 0 minus 1 by r minus 1. Just take negative common from numerator and denominator, you will get a by 1 minus r. This is now considered as S infinity, not Sn. S infinity. What is the meaning of S infinity? It is a sum to infinite terms. When you are adding infinite terms, the approximate value to which the complete series will converge is a by 1 minus r. Let us take this example. As we already have an example and as we already have an answer, let us try with this one. So if you remember, the first step I took it as 1, then 1, then 1 by 2. First term 2, then 1 by 2. So what is a here? A is 2. What is common ratio is 1 by 2. So substitute in the formula, S infinity is equal to a by 2 by a by 1 minus r. A by 1 minus r. 1 minus 1 by 2. So it is 2 by 1 by 2. This 2 gets here, which is equal to 4. So you can ask me the answer, sir, is the sum to infinite is exactly equal to 4? No. It is not exactly equal to 4 because it is going till infinity. So answer will be 3.9999999 and so on. It goes on forever and forever, but it will never converge to 4. We approximate that value to 4. So the formula for infinite terms S infinity is equal to a by 1 minus r. Let us take one more question. So this is the formula for this one. Let us do 3-4 questions on this infinite terms, sum to infinity, and then we'll go for the next topic, which is geometric mean. Same like arithmetic mean we discussed earlier, we also have geometric mean. Okay, let us have one question. Find the sum to infinite terms of a GP of minus 5 by 4, minus 5 by 4, then 5 by 16, and then minus 5 by 64, and so on. See, we have one positive term and negative term, one positive and negative, but still we need to find, we will try to see if the value converges to some value or not. Careful observe, if you take this as the first term, a is equal to minus 5 by 4, what is the common ratio? How do we get common ratio? Divide into consecutive terms, you will get common ratio. So 5 by 16 by minus 5 by 4. 5 by 16 into minus 4 by 5. Okay, this gets reciprocated. 5 and 5 gets cancelled, 4, and this is 4 times. So common ratio is minus 1 by 4. Is this value satisfying the relation minus 1 less than r less than 1? Yes or no? The same thing which also can be represented as mod r less than 1. Modulus absolute value function, mod r less than 1. Okay, so you have common ratio, you have first element. So what is S infinity? S infinity is equal to a by minus 5 by 4 by a by 1 minus r. 1 minus r is minus 1 by 4. So it is minus 5 by 4 by 1 plus 1 by 4. That is again 5 by 4. So this is minus 1. Let me check the answer. Yes, correct. So the sum of this to infinite terms, when you're going to infinite terms, it will be approaching to the value minus 1. It will be converging to the value minus 1. Understood? Let us quickly see one more question. Find the sum to infinite terms of the series root 2 plus 1 plus 1 plus root 2 minus 1. So next question is root 2 plus 1 plus 1 plus root 2 minus 1 plus so on till infinite terms. Acha, first tell me, is this in GP? We don't know that. Let us try to see the common ratio, and from there we can understand whether it is in GP or not. So if you take this as the first element, this is the second element, so the common ratio should be 1 by root 2 plus 1. Okay. And if you divide these two you will get root 2 minus 1 by 1. So are these two equal? No, sir, these two are not equal. How can this be equal? Carefully check. These are irrational terms, and we can convert this into, we can rationalize the denominator. See here, 1 by root 2 plus 1, I will multiply with root 2 minus 1 by root 2 minus 1. So what happens? The numerator is root 2 minus 1 by a plus b into a minus b, that is a square minus b square. Root 2 square this 2, 2 minus 1 is 1. Carefully multiply this 2, you will get the value 1. So this common ratio of these two terms and common ratio of these two terms are now equals. It is enough to say that this is following geometric progression. Okay, so first element being root 2 plus 1 and common ratio r is equal to root 2 minus 1. Okay, so S infinity is equal to a by 1 minus r. What is a? Root 2 plus 1 by 1 minus r. What is r? R is root 2 minus 1. Yes, so this is root 2 plus 1 by 1 plus 1, 2 minus root 2. So can we leave like this? We can leave like this, but always in a standard notation, we doesn't leave a rational number in the denominator. So that's the reason the concept called rationalizing the denominator comes here. Okay, so rationalize that one. 2 minus root 2 multiply with 2 plus root 2 by 2 plus root 2. So it will be, you multiply this one with this. Root 2 into 2 is 2 root 2. Root 2 into root 2 is 2. Plus 1 into 2 is 2. Plus 1 into root 2 is root 2. By denominator is a plus b into a minus b. A plus b into a minus b, which is a square minus b square. So 2 square 4 minus root 2 square is simply 2. So what you get? 2 root 2 plus root 2 is 3 root 2 plus 2 plus 2 is 4 by 4 minus 2 is 2. So let me check the answer. It should be 3 root 2 plus 4 by 2. Exactly. The answer is 4 plus 3 root 2 by 2. And once again, I'm telling you, if the person is new to here, the book I'm following is R.D. Sharma, Applied Mathematics, which is designed only for this course, especially Applied Mathematics 241. Which is being added as an elective from the academic year 2020-21. Okay, so this is the question 4 plus 3 root 2 by 2. Alright, so let us go for the next question. Let us solve one or two more questions and then we'll stop it here. Alright, 1 by 2 plus 1 by 3 square plus 1 by 2 cube. The next question is 1 by 2 plus 1 by 3 square plus 1 by 2 cube plus 1 by 3 power 4 plus 1 by 2 power 5. 1 by 2 power 5 plus 1 by 3 power 6 plus so on till infinity. Okay, so this is the sum. We need to find the value of s infinity. Now carefully observe, is this a GP? 1 by 2 is a 1 by 3 square. Then we again came to 1 by 2 cube, again 1 by 3 power 4. Sir, no common ratio between these two. We cannot find this one. Is that correct? I will just rearrange the terms and we will see what happens. So I'll write all the two terms together, all the three terms together, all the terms with 2. 1 by 2 plus 1 by 2 cube plus 1 by 2 power 5 plus so on till infinity, because we have till infinite terms, plus the next one is 1 by the first term 3 square plus 1 by 3 power 4 plus 1 by 3 power 6 plus so on till infinity. So are these two GP? Are these two comes under geometry progression? Yes, this is also GP, this is also a GP individually. So when you have these type of questions, you need to identify whether you can have two different geometric progressions. If yes, you can proceed very easily. See here. So here the first element is 1 by 2. Common ratio is 1 by 2 cube by 1 by 2. 1 by 2 cube by 1 by 2, which is 1 by 2 cube into 2, which is 1 by 2 square, or which is actually 1 by 4. Okay. So what is S infinity here? A by okay, 1 minus r, it is 1 by 4. So 1 by 2 by, this is 3 by 4. 1 by 2 plus 1 by 2 into reciprocate 4 by 3. So this one will be, the value of this one will be 2 by 3. The value of this one will be 2 by 3. What about this one? Same way, A is equal to 1 by 3 square, that is 1 by 9. The common ratio is 1 by 3 power 4 by 1 by 3 square. So 1 by 3 power 4 by 1 by 3 square, which is 3 square by 3 power 4, which is equal to 1 by 9. Even the common ratio is 1 by 9. So S infinity is equal to A by 1 minus R, that is 1 by 9. So 1 by 9 by 1 minus 1 by 9. 9 minus 1, if you carefully take LCM, it will be 8 by 9. So 9 and 9 gets cancelled, it is 1 by 8. The value of that is 1 by 8, the value of this one is 2 by 3. So what is the total sum? So total sum, if you can find, it is 2 by 3 plus 1 by 8. So what is the LCM? I'll write it once again. S is equal to 2 by 3 plus 1 by 8. So what is the LCM between 8 and 3? 24. 8 to 16 plus this is 3. So 16, 17, 18, 19 by 24 should be your answer. Let me check that one. 19 by 24 is exactly the correct answer. See what we have done. The given question we transformed into two different geometric progression because we can see the terms of that order. One is 1 by 2, 1 by 2 cube, 1 by 2 power 5, that forms a GP, and other is 1 by 3 square, 3 power 4, 3 power 6, even that forms a GP. So with both of this, two different geometric progressions, and finally add them up. Correct. Let us quickly see one more question and we will stop it here. One side of an equilateral triangle is 18 centimeters. So he has given the side of an equilateral triangle. Equilateral means all the sides are equal. One side of an equilateral triangle is 18 centimeters. See here. One side of an equilateral triangle is 18 centimeters. So if one side is 18, all the other sides are also equal to 18. Okay, beautiful question. See here. The midpoints of its sides are joined to form another triangle. So midpoints. So here is midpoint, here is midpoint, here is midpoint. So these three midpoints are again joined. Okay, these three midpoints are again joined to form a triangle. In turn, one more triangle is formed inside this one. Okay, so again the midpoint of this one, the midpoint of this one, the midpoint of this one. Again we are adding these two. Once again we get one more triangle. So in that way we are going till infinite triangles. The question see here. The midpoints of its sides are joined to form another triangle whose midpoints in return are joined to form another triangle. The process is continuous. The process is continued indefinitely. That means without an end, it is continued till wherever possible. Find the sum of perimeters of all the triangles and areas of all the triangles. How beautiful this question is framed. See here. Don't worry about the question. Just move as per the information you have. Okay. I'll draw once again. Before that, I'll tell you one concept which you already learned in your primary classes. If in an equilateral triangle, the side length is A. The side length is A. And if you're joining a line passing through these two midpoints, okay, in an equilateral triangle, this side length will be A by 2. That will be exactly half of that. That will be exactly half of that. These two are the line joining the midpoints of the other two sides. Line joining the midpoints of the other two sides. This will be parallel with this one, as well as it will be exactly half in size, half in length with the side. Okay, so what is the question now? We have a triangle of side 18 centimeter. Of 18, the first triangle has a side 18 centimeter. What is the perimeter of this one? What is perimeter of an equilateral triangle? Perimeter means sum of all sides. So 18 plus 18 plus 18. So it is 3 times of 18. Perimeter is 3 times of 18. Yes or no? This is the perimeter of first triangle. Plus, now we are going to one triangle inside whose side length is 18 by 2. Whose side length is 18 by 2. So perimeter of that 18 by 2, perimeter of that will be 3 times of 18 by 2. Correct? Next, we are going to form one more triangle inside joining the midpoints whose side length is half of 18 by 2. As much as you go inside, it will be half of that. 18 by 2, so this length will be 18 by 4. So what is the perimeter of that? The side is 18 by 4. Perimeter is plus 3 times of 18 by 4 and plus so on till infinitum. So up to where we can go, we are going in that way. So if you carefully observe, first element is 18, 18 by 2, 18 by 4. So common ratio is less than 1. Can you see that? Common ratio by 2 by 4. That means common ratio is 1 by 2, which is less than 1. And then we can apply S infinity formula. See here. So we need to find the value of this one. I'm taking 3 common. 3 times of 18 plus 18 by 2 plus 18 by 4 plus so on till infinity. Yes or no? So it is 3 times of A by 18 by A by 1 minus R. What is common ratio? 18 and 18 by 2. Common ratio is 1 by 2. Yes or no? So 3 times of 18 by 2 minus 1. 1 minus 1 by 2 is 1 by 2. That comes, reciprocates 1 by 2. Okay. So 18 2 is 36. 36 3 is 36 3 6 18 3 is 9 10 108 should be your answer. Just check my calculation once. So sum of all the perimeters of all the triangles formed in that will converge to the value 108. What about the area? You please proceed that. The same thing, area of an equilateral triangle is root 3 by 4 a square. So the first side is 18, root 3 by 4 into 18 square. The next one is half of that, that is 18 by 2 whole square and plus so on. So you need to carefully check what will happen to that. Yes or no? So you proceed from here and try to find, if this is first element here, what is the common ratio? What is the common ratio? Write 2 or 3 more steps, then you will understand what is the common ratio. Even that forms a geometric progression and you can find the area of that. Sum of all the areas. Alright. So this is about sum to infinite terms. We will end this here, and in the next class we will be dealing about geometric mean. Just like arithmetic mean we have discussed, we also have a geometric mean, which is very important, and we will continue that in the next class. Thank you.